And welcome back. We are going to go ahead and continue our work with linked lists, specifically looking at how we can apply generics to linked lists and also how we can implement our equals method into our code. So getting started here with our linked list generics, we already know previously how to use generics. We've explored them and we can see it's pretty simple. Well, we can take those same things to create generic linked lists. Well, generic linked list is going to have the same methods. It's going to be coded the same way as our previous linked list. However, the biggest difference is we're going to use a type parameter for the type of data within the nodes. Now note, if you want multiple pieces of data in each node, so for example, let's say you have 3 parameters you want to plug in, no problem. You simply just use a class type that has multiple instance variables and plug in this class for the type parameter t. Now there is a pitfall to be aware of, and that's using node instead of node t. In any generic linked structure with a node inner class, the type parameter need not be t and the node class name need not be node. But for simplicity, let's just go ahead and say that it's always going to be t in node. So when you're defining the generic linked list class, the type for a node is simply just node t. Now, it can be easy to forget the type specification, t, and simply just write node instead of node t with the brackets. If you omit that bracket to t, you may or may not get a compiler error message depending on the other details within your code. If you do get a compiler message, well, it might seem a little strange, like why am I getting this error here? And that has to do with us, again, using node instead of node t. Because a node is actually something that means, hey, I have a data type object and I'm doing something rather than a data type t, because remember t is a type parameter. Your only defense against this pitfall is to be very careful. If you do get a compiler error, oh, there's a error here. What do I do? Oh, I should see first if I am missing that bracketed t next to my node. Now, sometimes a compiler warning message can be very helpful when you make this mistake. It might say, hey, do you mean to have a type parameter constructor here? Oh, yeah, sure. Let's go ahead and fix that up. So if you do get a warning, remember, warnings are not the same as errors, that mentions a typecast from node to node t, look for that omitted t. Finally, we should note also if sometimes your code will compile. All right, it may not always have an error. It might not give you warnings. It might just run like it should, and it'll even technically run correctly if you omit that type parameter out of there. So there are some times when it does work, but it is something to just be careful about because it might work in right now, but there might be other instances where you plug in different type parameters and all of a sudden your code may start breaking. You're like, well, why is this doing this? Now, the other thing we need to talk about is the equals method for linked lists. The linked lists, of course, we've presented so far don't have equals methods. If you look at our code, there's no equals in there. All right, we did that simply because we want to keep the example simple and we don't want to necessarily detract from the main message of how we use linked lists. However, just like any other class, a linked list class should normally have an equals method. Now, there's actually more than one approach to defining a reasonable equals method. Either we can say, hey, we're going to say 2 linked lists are equal. They have the exact same data entries. They might be ordered a little differently, but that's okay. Or the 2 lists are equal if they contain the same data entries in the same order. That is, the data of the first node of the calling object is equal to the data of the second node, and the calling, second is equal, third is equal, and so on and so forth. Now, you might know it was like, why do we have 2 different equals approaches? Like one has order, one does not. Well, in different situations, you might want those different definitions. The most common way is to define equals is for linked list approach 2. So we're going to say, the first node is equal to the first node of the second list. The second node is equal to the second node of the second list. And our definition of equals that follows approach 2, we could easily add that to like our linked list 2 that we had previously worked with. Or even linked list 1 if we really wanted to add some implementation. Now, the generic linked list is also going to have an equals method, and we're going to see that here in a minute. That's going to follow approach 2. Now, note that when we define equals for our linked list with the type parameter t, we're trusting the programmer who wrote that definition of the type plugged in for t. So we're assuming that it has the appropriate methods within it. We're also assuming that the program has redefined the equals method so that it provides some repeatable tests for equality. We're hoping that whatever type parameter is being plugged in here, they have their equals method and it's working properly. Now, these kind of situations are the reason why it's always important why we have an equals method. We saw always have an equals, always have a toString. This is one of those reasons. When we start having things like type parameters or linked data structures where we need to start doing these tests, this is when that equals method is really going to come into play for us, and it's really important that we have that set up within our classes. So if we look at linked list 3 here over in Eclipse, and the big thing I want to point out down here is, of course, if we scroll all the way down, you'll see we have our equals method. And our equals method is a little different than what we might have seen before. Of course, it is using the proper way to define equals. We have an if, an else if. And if you look at our else, what it's doing, it's literally taking the linked list and comparing it to another linked list object. And it's looking at the position to the head. And the other position is set to a list.head. And what it's doing is it's going to say, hey, as long as that position is not null, let's go ahead and say if that data is equal to the other data. And, otherwise we have a false here. And otherwise, update the position until we go through. And if we return true, there's no mismatch. All right. In other words, every list item matches between list 1 and list 2. We're going to have a equal. Now, the other thing, of course, to kind of point out here is when we start looking at this is through the generic lens. If we look at this, you'll see it says linked list entry list. Entry, of course, is a new class that we just made up for this example. It's very simple. You can see it takes in, we got 2 data types here. We got a string and we got an int. And here's our constructor for it. And it has a toString and it has an equals method. Now, normally we'd have other methods in here like accessor, mutators, anything else we want with this class to do. But again, this is just a quick example for us to use. And so we're just kind of keeping it bare bones. And so let's go ahead and run this class here. And so we're going to go ahead and run the generic linked list demo. And you'll see we get list has 3 nodes. Makes sense. We have apples, bananas, and cantaloupe. Of course, this is the first item in the list. So that would be the first item printed. And then we get to the end of the list because we're simply just, again, we get the size of the list and we're outputting it and that's the end. But again, this is a generic one because, again, you can see we have this entry in here. If I didn't have this in here, if I tried just running this as a normal node list, so now we get a bunch of warnings in here. It says it's a raw type. References to generic linked list type T should be parameterized. So even though this is now, it's not giving an error, if I try running this, you notice it does work. However, it's saying I should, of course, have that entry flag in there. So that's an example of one of those warnings that you might see in your code if you have that type parameter missing from your node.